I won't talk about the coordinates, but there we are. Y equals x squared minus 4x minus 5, it says there. I've gone from minus 2 to 6. I've drawn it in, and trust me, it's quite hard freehand working on one of these little pads. I've labelled it, again emphasising that y equals 0 is the x-axis. And I've got to solve these equations by using my graph, your graph it says, and making other suitable straight lines. So in other words, there's going to be some linear twist to this. And here's the first one I've got to solve. I've got x squared minus 4x minus 5 equals 0. Well, clearly I've got to use the line y equals 0 as before, usually the starter, and my solutions are there and there. So I've got x equals minus 1, I'll do the solutions in red, and this one just here, I've got x equals 5. Alright, two solutions we said about that. And the next one, I've got to solve this one. X squared minus 4x plus 4 equals 0. I have got to go, I've got y equals x squared minus 4x minus 5. Easy, look at that. And that's going to equal to 0. Now let's see how to make it relate to the previous one. Now, that's a match, that's a match. How do you get from plus 4 to minus 5? Answer, you subtract 9, so subtract 9 from each side, and therefore I've got the graph of y equals minus 9, and y equals minus 9 is straight across here. So y equals minus 9, bam, straight across there. Oh, that's not brilliant, is it? Yeah, good enough. Label up in blue, that's the graph of y equals negative 9. And I've got one solution right there. Besides, look, here it is, here, 2 minus 9, so I can see that when y equals minus 9, x equals 2, just there, alright? And my solution is therefore x equals 2. Just one solution. Incidentally, while I'm talking about this special case, please note that although we have a curve, not all straight lines will cut through in two places. In this situation here, we've got a straight line intersecting the curve at just one place. I know it looks like the graph has dipped there a little bit. That's just my poor drawing of it, but really we'll pass at the minimum point 2 minus 9. Therefore, when y equals minus 9, it will intersect the graph at the point where x equals 2. And there is one solution only to this. There it is, just right there. In fact, let me just highlight it as the unique situation where it cuts it in one place. And that being the case, therefore, you should recall that where a line touches a curve, just like in circle theorems where a line touched the circle on the circumference, this is called a tangent. So this line forms a tangent at the point 2 minus 9. Isn't that lovely? Alright, so that line is a tangent at the point 2 minus 9. Do look at that and refer to it and remember it. And we'll do the last equation here, then move on. And so here's the last one. I've got to solve this one. X squared minus x minus 6 equals 0. Compare with the original. I've got y equals x squared minus 4x minus 5 equals 0. Right, plenty to do here. How does one get from x squared to x squared? No difference. What about minus x to minus 4x? We need to include minus 3x, don't we? So we want a minus 3x to match it now. How do you get from minus 6 to minus 5? You've got to add 1. And of course do this to both sides. Minus 3x, add 1. Therefore, I want to plot y equals y equals 3x minus 1. That and that. Alright, just put it on the side here. Oh, by the way, that was y equals minus 9, which I've drawn. This will be y equals minus 3x plus 1, or 1 minus 3x. Again, get a few coordinates there. If I pick a value of x equals 0, I've got y equals 1, so I've got 0, 1. I think I'll apply it now. That's right there. If I go for, I don't know, let's go for x equals 2. So if I've got x equals 2, for example, I've got, if I just choose the 2, so minus 3 times 2 is minus 6, minus 6 plus 1 is minus 5, so it'll be 2 minus 5, so 2 and minus 5 right there, and there's my straight line. Let's try and do this faithfully then. I've got to start from here because I can't guess from a distance, so if I put that right there, happy with that. If I extend back, hopefully that'll also be true as well. Okay, there's my line. Let's just label it quickly in blue so it's pretty. And this one is y equals minus 3x plus 1, clearly a negative gradient. And my points of intersection I'll highlight here and here. And I put my answers here, I reckon. So my solutions are x equals minus 2 and x equals, this one here, 3. So again, I'm not sure how accurate these are, but the general sense is correct, with the limitations of a freehand curve and freehand software and all the rest of it. So I'm going to stop there, check out my answers and get back to you if I need to.